Let's take a look at how to find probability from a normal distribution. And let's look at how to do this calculation using two techniques. Number one, we're going to look at how to use the standard normal distribution table of values. And also, let's look at how to use technology. Let's look at how to use Minitab to do this. I think it's a good idea to know how to do it both ways. Both ways are fairly simple, so it'll only take a minute to show you both techniques. If you haven't done so already, be sure you print out the corresponding guide sheet that goes with this demonstration. It'll really help you capture this information in a neat and concise way, and make sure that you get all of the important points that I give you, and then you'll have this information that you can reference later when you need it. In our examples, we're going to assume that values are normally distributed with a mean of 0 and a standard deviation of 1. So let's find the probability of a score less than negative 2.04. The most important step in any problem such as this is to sketch your curve. So if you don't have a curve on which to draw, you can just sketch a curve. It doesn't have to be perfect. You can just sketch a line with a curve over top, because this is just a sketch for you to visualize what area you are searching for. Label the given information. In every single normal curve, your mean is going to be in the middle. In this case, our values are normally distributed with a mean of 0 and a standard deviation of 1. Shade the region of interest. Our z-score of negative 2.04 is going to be to the left of the mean, because all negative z-scores are to the left of the mean. So anywhere over here on the left, it doesn't have to be exact, just somewhere on the left, draw a line for negative 2.04. And again, this is a sketch. It doesn't need to be exact. We want to know less than 2.04. So the area that's less than 2.04 is going to be this area right here. So now I have an image of the area that I'm trying to find. So I need to get a normal distribution table on which I can look up the area. Let's take a look at this negative side of the z-score table. Look at the image that's at the top of this table and notice that it matches our image. That's telling us that this z-score table, the values in the middle of the table, are giving us the area in this blue part that's shaded. So any z that we find up to the value of 0 is going to be that cumulative area up to that z. So we're interested in 2.04, negative 2.04, up to that point. So we come over on the left and we find negative 2.04. So we find negative 2 and we come over to 0.04. And we find that the area in that shaded region is 0.0207. So this tells me that my area for this part of my curve is 0.0207. So the probability of a score less than negative 2.04 is 2.07%. Let's take a look at how we can do this using Minitab. Let's take a look at how to do this same problem in Minitab. I still want you to draw your sketch, and the reason for that will become apparent in just a moment. Once you're in Minitab, go under Graph and go under Probability Distribution Plot. If you've been working with me for a while now, you've been going under Probability Distribution Plot to solve your binomial and your Poisson probability problems, so you're accustomed to using this handy tool. Once you get under there, go to View Probability and click OK. Once you get there, you're going to go to the distribution options, and probably normal probability is already selected, as that is where the program defaults. If it's not, make sure that you use the drop-down box and select normal probability so that Minitab knows that that's the type of distribution with which you are working. You'll enter in your mean and your standard deviation. If you're just given z-scores, then your mean and standard deviation are standardized and they're just 0 and 1. If you're not working with z-scores and you haven't converted into z-score, Minitab allows you just to go ahead and enter in your mean and standard deviation as given, and it will calculate your probability as is. So that's pretty cool. You don't have to calculate your z-score when you're using Minitab. You do not have to standardize your information. You can just enter it in as it's given. So it really takes a lot of the work out of this process for you. So before we're going to click OK, we can't do a calculation just yet, we need to click on Shaded Area. And this is where your sketch really comes in handy, because that's going to let us know which one of these options we need to choose. Now, we're going to define our shaded value based on an X value. We're going to define our shaded value based on where we drew that line on our sketch. We have a value at negative 2.04. We have a value, we don't have a probability already given to us for which we're trying to find a value where that probability sits. We already have an X value along, or actually a Z value, but Minitab calls it an X value. We have an X value for which we're trying to find a probability. So look at your sketch and which one matches the pictures here on the screen. Well, we want to know the left tail, so that's the one we click. And then which X value or Z-score are we looking for? We're looking for negative 2.04. So now we've given Minitab all of the information it needs, and we can click OK. And there's our curve. It should look exactly like the one you have sketched on your paper. And it tells us that the probability at negative 2.04 is 0.02068, which is exactly what we calculated when we did the problem manually at 2.07%. So Minitab does it with, a lot more speed and ease, but, you need to know how to do it by hand as well in case you don't have the program right there, handy in your computer right there with you. You can still do it with the table and manually. So let's do another one. Let's take a look at the probability of a score greater than negative 1.50. Again, we're going to assume the values are normally distributed with a mean of 0 and a standard deviation of 1. As always, the most important step is to sketch your curve. And this is a problem where you're going to see why this is extremely important. Again, the mean is in the middle. My z is to the left of the mean, once again, because it's a negative value. So sketch it anywhere to the left and label it negative 1.50. But this time, I want to know the probability of being greater than my z-score. So I'm interested in all the values to the right. So again, I need to look at my area on the normal distribution table. So let's get our normal distribution table up again. So here we have our negative distribution table. Recall that in this table, the areas are being given in the tail. But in this problem, we need the area over here. That's not a problem. Let's look up the area in the tail. We need negative 1.50. So let's come down here to negative 1.5 and come over to 0.0. So it's 0.0068. So the area right here is 0.0668. Well, I know the entire distribution is 100%, or 1, since I'm working in decimal form. So if I know if up to this point is 0.0668, and I know that the whole thing equals 1, then I can find the unknown portion by subtracting what I know from 1. So I say 1 minus 0.0668. 2.8 to get the unknown portion. So my unknown portion is 0.9332. So this value over here is 0.9332. So my probability of being greater than negative 1.50 is 93.32%, which really makes sense if you look at the shaded portion of that bell curve. It's approximately 93% of that bell curve is shaded in. A large portion of the bell curve is shaded in. It makes sense. Let's take a look at how to solve this one using Minitab. So now let's run through this one in Minitab. Again, go to Graph, come down to Probability Distribution Plot, View Probability, click OK. Once again, we want normal. We're already in z-score, so our mean and standard deviation are 0 and 1. Go under Shaded Area, and we want x value. Now in this case, we're not interested in the left tail. Look at your shaded sketch. Which one matches? We want greater than in the right tail. We're going to the right. So we want the right tail sketch. And our value in this case is negative 1.5. And if you want your 0, you can put it in there, but you don't need to. Click OK. And look at your sketch. Look what comes up. It should match exactly what you have drawn on your paper. Your probability is 0.9332. And that makes sense. It matches what you calculated by hand, 93.32%. Let's just go back for a second. Let's close that out. We don't want to save that. I'm going to go back and look at your shaded area. Let's say you made a mistake. And instead of typing negative 1.5, you typed in 1.50 and you clicked OK. That doesn't match your shaded area or your sketch. That should tell you you probably made a mistake. So that's why it's important to draw that sketch, because then you'll know that you have that comparison. You can look and see that, hey, what Minitab just gave me doesn't really seem to make sense. It doesn't match what I drew on my paper, so it's probably wrong. I did something wrong. I typed something in incorrectly. I better go back and make sure I didn't miss a negative sign or I didn't do something wrong. So it's a good idea to have that sketch for comparison, and it only takes a second. It's not as if it takes all day to draw that sketch. So I really, really want you to get in the habit of drawing that sketch. So this time, instead of finding the probability and lying in one or the other of the tails of the normal distribution, we're going to find the probability of lying in between two z-scores, which really isn't any more difficult. It's just a different technique. We can still use the normal table, or we can use Minitab. So let me show you how to calculate this both ways. Again, let's sketch the curve. So our first z-score is going to lie over here on the left at negative 2.20, and our other z-score is going to lie over here on the right at a positive 2.5. And I want to know the probability of falling in between. So I'm going to need my z-score chart to look up these values. In this problem, I need to work from my negative chart as well as my positive chart. So first let's look up our negative z-value of negative 2.20. So looking more closely at this chart, I see that negative 2.20 is an area of 0.0139. But that amount is right here in the tail, 0.0139. And in our positive 2.50, let's see what that is. That's at 0.9938. That value, notice, goes from this tail all the way up to here. So it starts here and it goes all the way up to here. So that amount is 0.9938. So we have counted this portion twice. We've overlapped. So what we need to do to find this area in red that we're interested in is subtract the two areas to get rid of this part that's been counted twice. So we need to say 0.9938 minus 0.0139 to get the area that we're interested in, which is 0.9799. So the probability of being between negative 2.20 and 2.50 is 97.99%. So finally, let's take a look how to do this last example in Minitab. Okay, we've got this last one. We're going to take a look at it. We're going to find the area between two z-scores. We've already found it by hand. Let's see how quickly we can do it in Minitab. Again, go under Graph. Whoop, I dropped it there. Probability distribution plot. View probability. Click OK. I'm under normal. I'm already in z-score mode, so I'm going to leave my mean and standard deviation as 0 and 1. Shaded area and x values. So now I want to know between two values. So I'm going to click this one down here. And see how Minitab gives me the option to put in two values now. So the value on the left that I want to have as a barrier here, I'm having a slow responding computer here, negative 2.20. And on the right, I want my boundary to be a positive 2.50. And then click OK. Wow, that's a lot of area. So we should see a pretty high probability, 97.99%. That makes sense, and it matches the sketch we drew. So that was pretty quick and pretty easy. It's good that you have the sketch to compare to make sure that you plugged in the right z-scores. So now you've seen how to do it both ways. It's up to you how you want to work these problems. I recommend being able to do it both ways, but I'm telling you the key to getting these problems right is sketching that curve. It helps you to identify and send up some red flags if you're not plugging the right thing in. Just having that curve as a reference makes all the difference in the world. So good luck with your normal distribution problems.